Hello fellow problem solvers, so they're going to be doing a problem from the 1994 IMO, problem number 5. I suggest you try this nice function out for a minimum of 15-20 minutes, ideally an hour to an hour and a half, not more than 3.5 hours. If you'd like to go along with us, give it a go for the next 15 minutes. And now let's begin. So, what do we have? Find all functions from the set of, numbers that are greater than -1 that are real. Okay, that satisfies this relationship. Okay, so what do we have here? So f of x equals x seems to be a solution to this functional equation for x, y, and s. Y is s minus 1 to 1. And we have, this is strictly increasing on each of the two intervals. Okay, so f of x equals x is not a solution, and we need to use this fact somehow. Okay, so now let's see, what are we going to do here? Well, let's plug in, say, a 0 anywhere. Let's see if we plug in, let's call this like condition 1. So in another way, we can also say like this equation is p of xy implies this thing right here. And now just instead of writing down, let's plug in x is 0, x is 2, x is 0, y is 1, we can just say p of, say, x and 0 implies what? So f of 0, it implies f of x plus, what's this? F of 0 times x plus 1 is equal to f of x, just f of x. So f of this is equal to f of x. Okay, let's see, what else can we do? When we plug in x is 0 and let y hold, that's actually a bit interesting. You know, does this force f of 0 to be equal to 0 is my question. For example, if it's not equal to 0, if these two are in the same interval, we would get, I believe, maybe a contradiction, or maybe we would have that this either so this is always positive. Now if f of 0 is negative, then this whole thing is negative, so this is smaller than this. For a large enough x, we can have, maybe there's a thing to look at here. But right now we're just plugging in a couple of stuff and seeing what is it that we have. F of 0 and y, we have a 0, 0, we get f of y is equal to what? We get a y, we get y plus f of 0 times y plus 1. So sort of the same thing we just had over here. Now maybe if I instead of f of x, instead of x, I plug in f of x, I can get it down to this thing right here. That could be cool. Is there a way to equalize, for example, let f of x be equal to this? And the answer is, doesn't seem like it. We would need to have f of y times x plus 1 would need to be, 0. So if there's something that's equal to 0, actually let's see what would that mean. Maybe that can give us a bound on how many things can be equal to 0. And here's where I can actually invite you to pause for 10 minutes and see, what would you do here? If there's anything else you would do. Maybe look at this strictly increasing thing. So now, for me, let me just see like this f of 0, how many things can be 0? Let's say f of some alpha is equal to 0. And then, like, if such an alpha exists. And I think from here, maybe it does exist. Like, say f of 0 is equal to some constant c. Then we have y plus cy plus 1, I want this to be 0. I want y times c plus 1 to be equal to minus c. I want y to be minus c over c plus 1. And I need this thing to be in S, to be able to put it in. Now that makes c isn't equal to -1 for one thing, and for the other thing, so when is this? So if c isn't equal to -1, then that's okay. So if c is, so this is positive, the question is c positive? If this is greater than 0, then this is less than 0, then I need c over c plus 1 minus this. I need this to be greater than minus 1. In other words, I need 1 to be greater than c over c plus 1. And this is in fact true. If c is less than 0, actually wait, this is if c is greater than 0, then this is positive. If c is less than 0, then this thing right here is positive, and then I need c over, then I'm good actually, then this is positive and such a y exists. So in either case, there is going to exist a y such that f of y is equal to 0, right? So f of f, so there is at least one alpha such that this is the case. And maybe this also tells us by injection, maybe we can have an injection. If f of a is f of b, then f of a is f of b, and then we have a times c plus 1 is equal to b times c plus 1 from just this equation right here. And then this implies a is equal to b. So the function is in fact injective, it seems, if we haven't made any mistake, it's injective. And so now is f of x equal to this? So now it's f of 0 times x plus 1 needs to be, like these two things need to be equal. So we have f of 0 is in fact equal to 0. And we're done. And there's only one alpha such that this is the case. So it's f of 0 equal to 0. There's not much else to say here, and we have f of y is equal to y. And yeah, that's pretty much the thing we have. So when f of y is equal to y, this also means that the function is a surjection, a bijection. Because if we need a z, we'll just plug in f of z, and we'll get f of z is going to give us a z. So now we have that. Okay, that's cool. Is there anything else we can really do here? There's an x such that f of x is 1. Maybe that can, then we can, if we set up, if I set up y to be something between, I want y to be 1 so I can just have f of x alone, but it doesn't seem to, so I can then like have f of something is f of something else, but that doesn't seem like something I'm going to be able to do. And I'm still not using, the thing that's bugging me is I'm not using this thing right here. Let's continue. So let's plug in x and x, just like, let's see what happens when we plug in two things which are the same. What do we get? We get f of x plus f of x plus x f of x is equal to x plus f of x plus x f of x. Okay, now what does this tell us? I might actually pause for about 5 minutes, 10 minutes and ask yourself, does this tell us anything? And the answer is it does. It tells us there is some c, let's call this alpha. There exists an alpha such that, like alpha that's from S, such that f of alpha is equal to alpha. Right? That's what we have from here. And if you think about now this condition, we can have, how many alphas can we have? We can have alpha be 0, right? Because then this is not touched. But we can't have two separate alphas, two separate values that this is equal to on the interval from -1 to 0, or from the interval 0 till infinity, right? So this thing right here is equal to, can be equal to three different values, a positive, a negative, and a 0. And that's how we can use this condition, and that maybe tells us something about this. And this is satisfied. Now the question is, can we have some positive x such that f of x is equal to x, right? Because this is that. Okay, but what happens there? And here's where I invite you to pause for another 10 to 15 minutes to try to push the problem further. And now, let's continue. So what do we have? We have there exists an alpha. Let's say that this alpha is positive. Let's say there exists a positive. if alpha is greater than 0. What do we have? So let's plug in, I don't know, I think I want to plug in y is equal to alpha because I can get rid of these f's. And then let's see what happens. It doesn't make sense to plug in alpha and alpha because I'll just get, actually, or it doesn't make sense. Maybe it does because, wait a second, if I plug in p of alpha and alpha, I'll get f of 2 alpha plus alpha squared is equal to 2 alpha plus alpha squared. And now can this thing is going to be positive, right? There's no, if alpha is greater than 0, then both of these are greater than 0. But they need to both be equal to alpha. And that tells us that alpha times, I'll get rid of these alphas, that'll give me alpha squared plus alpha is 0. In other words, alpha times alpha plus 1 is 0, alpha is positive. That cannot be the case. And, oh, so, so alpha can't be positive. So let's say if alpha is negative. What happens then? Next, we can, again, let's see what happens when we plug in both of these. We'll get f of 2 alpha plus alpha squared is equal to alpha squared plus 2 alpha. And now these two, this thing is going to be what? It's, f of something is, this is the same as alpha times 2 plus alpha, which is a negative value, because this is negative, this is positive. If alpha, like alpha is between 0 and -1. And now this thing needs to be equal to alpha as well, because it's another negative value. And if it's a negative value, you can only have one such thing here. So we get this is equal to alpha, and then either alpha is 0 or alpha is now -2. If alpha is not 0, did I mess up the, I think if I messed up the math, it still doesn't matter. Alpha times alpha plus 1. If I divide by alpha, I get alpha plus 2 is 0. Why do I get -2 here? And here I did not get that. Oh yeah, alpha plus 2 is equal to 1 when I divide. I was just like, you see, I even sometimes mess up the algebra. Free bronze medals, still mess up the algebra. It's okay if you do that. So let's see, what do we have? We have this thing is equal, and from here we have alpha isn't 0, we assume it's negative. Then we have 2 plus alpha is equal to 1. Alpha is equal to -1, which is outside of the range of s, greater than -1. So there can't be so this is never equal to a negative or a positive number. Like f of x is equal to x implies that x is a 0. And this is also looking at fixed points of the function. Another sort of way to see like what are the, like f of x isn't equal to x for all x because of this condition. And by looking at places where it is, where I think near finishing the problem, actually we have in fact finished the problem, because now this implies we have f of a is equal to a, and that implies a is equal to 0, which gives us that this implies that x plus f of x plus x f of x is equal to 0. And now we need to do some math. So we have f of x times x plus 1 is equal to -x, and then f of x is equal to -x over x plus 1. This is what f is forced to be. And if we plug, now we need to plug those in here to check that this is the case and check that this is strictly increasing on both of these intervals. So now I invite you to pause for 10 minutes and just do that. And here's how we're going to do that. So let's now first check that this actually works for all x and y here. So what will we have? We will have f of y, we'll have x, f of this which is f of y times x plus 1. This will be equal to f of x plus, maybe x times f of y. What is f of x plus 1? It's like 1 minus this. Wait, so 1 plus f of x is equal to x plus 1 over x plus 1 minus x over x plus 1 is equal to 1 over x plus 1. So I want to do that the other way around. I want to write this as x times f of y plus 1 plus f of y. And then this becomes f of x over y plus 1 minus y over y plus 1. So this is x minus y, so this is f of x minus y over y plus 1. This should still be in range if x and y are between 0 and 1. I think we do need to check that this is still actually between in the set S, this value right here. If x and y are in S, then this is in S. How can we check that? What is my sort of worry? My worry is if y is bigger than x, does this remain in S? Let's see, if y is a lot bigger than x, this is like 1. Or maybe x can be negative. Okay, but x cannot be super negative. We would still need to check, we'll check that separately, but let's just check that this function actually works out. So we have f of this needs to equal, we have now y plus 1, then we have y f of x plus 1 plus f of x, and this is going to give us y times 1 over x plus 1 minus x over x plus 1. This is going to give us y minus x over x plus 1. Interesting, it's like they switched sides. And we need to show that this, when we apply f, is going to equal this. And what do we have when we apply f? We'll get negative, so let me do the negative instead of y minus x over y plus 1 over this plus 1 over x minus y over y plus 1 plus 1. And then the plus 1 is really plus y plus y plus y plus 1 over y plus 1. And now I can cancel out the y plus 1s, and this cancels out the y's, and I get this is equal to y minus x over x plus 1 over x plus 1 because the y's cancel out. Okay, so the f condition is true. Let's just check that f of, I think what I have, let me double check this. Let's double check that this is actually in range. So how do we do that? We need to show that x minus y over y plus 1. We need to show that if this is less than 0, that it's greater than minus 1. Okay, so if this is less than 0, we know y plus 1 is positive, so we can multiply everything by y plus 1. We need x minus y to be less than y plus 1. Wait, but this is positive. Wait a second, am I losing sense here? This is positive. If this is less than 0, then this is negative. That means y is less than x. Actually, no, it means x is less than y. And so this is in fact the case. Huh. Interesting. Yeah, because this thing right here is less than 0, this is greater than 0. And so we're done. Yeah, because this thing right here, but it feels like I've messed something up mathematically here. X and y are less than. I'm just double checking now. This is positive. this is negative. Because this is negative, y is greater than x. Because x minus y must be less than 0. Okay. And so I can multiply when I have... Actually, no, when I multiply, I get a 0. What am I doing? I get a 0 here when I multiply for everything by y plus 1. And this is in fact the case, so we are good. I felt something was off. I multiplied incorrectly. And if x minus y is greater than 0, or if x minus y or y plus 1 is greater than 0, then we just need to, then this is just greater than 0. That is okay. So this is in range. So this is within S as well, so we are good, not in range. It's within S, so we are good. And also, is this always in S? And it seems to me to always, it always is in S, because 1 plus f of x is always going to be greater than 0. Because x is greater than minus 1, so this is positive. And because 1 plus f of x is greater than 0, so we have that everything's still in range. That's also an interesting way that by playing around with this to like ease up my algebra, I also had a quicker way to show that f of anything is still in S. And you have to do that when you're like discussing with these sets, when you're playing with these sets. And now what do we have? We need f of x over x. So we have f of x over x is going to be equal to, the x's cancel out, it's going to be equal minus 1 over x plus 1. Okay, so strictly increasing on each of the intervals. If x is greater than 0, then in this interval, interesting, no, I had to have messed up here. Oh, I can only divide. I thought when x is 0, I'm not getting 0, but I realized it would be 0 over 0 indeterminate form, so I can't do that. But in both of these intervals, if x is between minus 1 and 0, I'm just like now going through my head, like when is this positive, negative? Because this is a very interesting problem, in my view. In my view, this is a very, very cool problem. So for x between 0 and minus 1, what do I have? I need to have that if a is less than b is less than 0, greater than minus 1, then I need to have that minus 1 over a plus 1 is less than minus 1 over b plus 1, which is true if and only if 1 over b plus 1 is less than 1 over a plus 1. Both of these numbers are positive, and because a is less than b, this means the absolute value of a is greater than the absolute value of b. Do I want to use this actually? Let's not. Let's multiply through by a plus 1, b plus 1. I need to have a plus 1 less than b plus 1, which is in fact true because b is greater than a. Okay, so that's this case, and in the case where a is less than b is greater than a and b are both greater than 0. In this interval, we need to have, again, the same thing. Minus 1 over a plus 1 less than minus 1 over b plus 1. And now this turns into the exact same thing. B plus 1 or 1 over a plus 1. A is less than b. So we've checked out both of these intervals are true. We checked f. That seems to be actually the bulk of this problem. I think the big idea here was to actually, when you plug in x and x, to see, wait a second, I have a value where f of x is equal to x. I have some a, actually I have an a where f of a is equal to a. I know I have that for 0. And because of this strictly increasing condition, I can only have that at 3 points. And then we figure out, wait, a negative point won't work, a positive point won't work, and so they will have to go to 0. And then you have what f of x is. And I think this is a different way of thinking than most common become functional equations. This finishes up our problem, and as always, thanks for problem solving.